Cybord Shield Scan compares every assembled board against an AI reference model to identify unexpected component variations. The model itself is built using a neural reference process that fuses data from a population of known good boards. In this video, we'll explain the neural reference process, or how to create a neural reference model. In this example, we've selected 22 boards, as shown here. The first step would be to ask the system to create a reference for all 22 boards, that is, to run the neural reference process. During this process, every board is compared against every other board in the selected population. Based on that population, ShieldScan builds the reference model, which will later be used to inspect all future boards. The system returns with an average reference board and identifies multiple variations. It's up to the user to decide which variations should be accepted and which should not. Some differences are immediately obvious. For example, in 22 of the boards, 20 components may look like the one on the right, while only 2 look like the one on the left. While building the model, the system asks whether both variations should be accepted. Users can approve only the right variation, only the left variation, or both, depending on their requirements. The system maps all 22 boards and groups visually similar components together. Then it presents the groups to the user for approval. If the user has already confirmed that all the reference boards are valid, she or he can skip the review. Just click Approve All and accept them all at once. However, if the user notices meaningful differences, it's advised to review them individually. The review process only takes a few minutes. Simply inspect each group and decide how to handle it. Let's look at an example. Here, the system tells us that 6 out of the 22 boards contain one variation, while 16 contain another. The user can choose to accept or reject either variation, or to approve both. Returning to the overview, every component is fully interactive. Clicking on a component immediately zooms in to its exact location on the PCB. Users can zoom in as much as needed to inspect the component in detail. This makes it easy to verify exactly where the component is located on the board. Let's have another look at the review process to understand why it's important. Here's one example. The system has identified 4 different groups. We can clearly see that these groups look different. Even the printed markings are different. In this case, both components are 270 ohm resistors, but one has a 5% tolerance while another a 1% tolerance. The question is whether the user allows both tolerance levels to exist on the system, or only one. The user may decide that only the 1% resistors are acceptable. In that case, the 5% variance can simply be rejected. Both of these are 5% components, while these two are 1% components. The user can approve the 1% versions and reject the 5% versions. That means only 1% tolerance components become part of the reference model. The same review process applies to every component on the board. It doesn't matter whether they're passive or active components. Any visual difference detected by the system is presented for review. All of these variations are highlighted because they appear within the selected reference population. The Cybord software prompts the user to confirm whether these variations should become part of the model or otherwise be rejected. More specifically, where multiple variations are detected, the user must explicitly approve them. Once everything has been reviewed, the user clicks Approve All. All changes are then saved, and the neural reference creation process is complete. From this point onward, any new board that enters the Cybord system would be compared against the model, allowing for more accurate inspection and eliminating false positives. Thank you for watching. For more questions, contact us at info@cybord.ai.